All right, let's get right into it. You hear all the time about AI getting smarter, right? But how does it actually learn to understand meaning, the way we do? Well, today we're going to break down a really cool framework that's helping machines do just that, bridging that huge gap between raw data and real human-like understanding. So the entire challenge for AI, really, it all starts right here. It boils down to this fundamental difference between just data and what that data actually means in the real world. And this slide just perfectly lays out the problem. A computer looks at a photo, and what does it see? Just a bunch of numbers. Pixel values for red, green, and blue, that's it. But you and I, we look at the exact same information, and we instantly see a concept, right? We see a smiling face. That massive difference, that giant chasm between the raw numbers and the actual meaning, that's what's known as the semantic gap. So, this really brings us to the million-dollar question, the one that's driving so much of this research. How in the world do we get a machine to make that incredible leap? How do we teach it to go from just seeing pixels to actually seeing a smile? Okay, so the solution, it actually starts by throwing out the old rulebook of traditional computing. It forces a totally new way of thinking, moving away from that rigid black and white 1 or 0 logic and embracing all the messy complexities of the real world. I mean, think about it. The world isn't just ones and zeros, right? It's messy. Is it hot outside or just kind of warm? Is that person tall or really tall? These things aren't just strictly true or false. They're ambiguous. They're fuzzy. So if we want an AI to actually understand our world, it needs a tool that can deal with all this imprecision. And that amazing tool is called fuzzy logic. So what does that mean? Well, instead of forcing a computer to say something is 100% true or 100% false, fuzzy logic lets it work with degrees of truth. So a concept like it's a warm day could be, say, 70% true. It's a game changer because it allows computers to reason with these approximate ideas, just like we humans do all the time. But here's the thing. Fuzzy logic by itself is just one piece of the puzzle. To make it really powerful, to make it something you can rely on for seriously complex AI, researchers needed to build a more solid, more rigorous mathematical framework around it. And this is where the key innovation comes in: Axiomatic Fuzzy Sets, or AFS for short. The best way to think about it is this. It takes that flexible, kind of human-like reasoning of fuzzy logic and gives it a super solid, predictable mathematical backbone. It adds structure, it adds rules, and that's what makes it such a reliable tool for building really intelligent systems. So how does this whole theory actually work? Well, you can think of it as being built on 3 main pillars. First up, you've got AFS structures. These are like the filing cabinets, the blueprints for organizing all that fuzzy data and giving it a place to live. Next, you have AFS algebras. This is the official rulebook. It defines exactly how you can combine different fuzzy ideas, like warm and sunny. And finally, there's AFS fuzzy logic itself. That's the engine that takes those rules and actually does the reasoning. All 3 parts work together perfectly to let an AI handle all this messy, ambiguous information in a way that's totally structured and reliable. Okay, so theory is great and all, but how does this stuff actually work in practice? Let's talk about one of the most powerful ways AFS is used, something called clustering. That's just a fancy word for grouping similar things together to find patterns. And here's what makes this so cool and so different from the old way of doing things. Standard clustering might just group a bunch of photos based on their color palettes or something. But AFS clustering, it aims way higher. It's not just grouping data, it's trying to create clusters that represent actual, meaningful, human-like concepts. Think about a cluster for happy faces or one for surprised faces. See the difference? And the advantages of doing it this way are just massive. For one, the models are transparent, which means we could actually peek inside and see why the AI made a certain decision. They're understandable, they're interpretable. What's more, this approach works with all kinds of data, numbers, text, you name it, and it uses simple linguistic rules that make sense to us. It really hits that sweet spot, that perfect balance between being super accurate and being something we can actually wrap our heads around. Now this right here, this is the secret sauce. This is what makes ASS so incredibly unique. It has this superpower. It can handle 2 totally different kinds of unknowns at the exact same time. The first kind is what we call subjective imprecision. That's just the fuzziness of human language, like saying it's warm outside. The second is objective uncertainty. This is pure statistical randomness. Think of a weather forecast saying there's a 50% chance of rain.
ASS is able to bring both of these concepts together under one roof, creating a unified theory for our messy, unpredictable world. It's pretty incredible. All right, let's pull the camera back for a second. What does all of this mean for the future of AI? What's the real big picture impact here? This quote from the research really just nails it. The goal is mimicking the human reasoning process. I mean, that says it all, doesn't it? The ultimate goal here isn't just to build a better calculator, it's to create an AI that can actually reason more like we do, not just by crunching numbers, but by truly understanding concepts and context. And listen, this isn't just some far-off theoretical idea. This is happening right now. It's being used to pull out those fuzzy, semantic descriptions from faces, identifying things we understand, like a pointed nose or a broad smile. It's being used to build much smarter decision trees, to uncover hidden gems of knowledge in enormous datasets, and really to create a whole new generation of systems that can think in those important shades of gray. So what's the bottom line? What's the big takeaway here? It's this. By teaching machines how to bridge that semantic gap, we're not just making them more powerful. That's only half the story. We're making them more transparent. We can finally crack open that black box and understand how they think. And that right there is the absolute bedrock for building AI that we can actually genuinely trust. And that leaves us with a pretty deep final thought to chew on. We've seen how AI can be taught to grasp the meaning hidden in our data. But the next giant leap, and maybe the ultimate question, is this. Does learning our meaning eventually lead to an AI that can truly understand us? Something to think about.